Okay, in this problem we're going to work a related rates problem. Here's the problem. Water in a tank the shape of an inverted cone with a depth of 10 meters and a top radius of 8 meters is leaking water at a rate of 0.004 h squared cubic meters per minute, where h is the depth of the water in meters. Can the tank ever overflow? Well, there's something I forgot in this problem. Water's also being poured in at 0.1 cubic meters per minute. So let's take a look at how we can approach this as a related rates problem. And so we need to take our knowns and our unknowns, and I'll bring the problem back as needed. So first off, we need to think about, we're looking at our change in volume with respect to time. And we were given two things. We have two things. We have a rate that the volume is coming in with respect to time minus the rate that it's going out with respect to time. And both of those were given. I kind of gave the last one because I forgot to put it in the original, but it's coming in at 0.1 cubic meters per minute, and it's going out at 0.004 h squared cubic meters per minute. So that would be our dV dt, and that's given. Now the other thing, let's get a picture of our inverted cone here. We know it has a top radius of 8 and it's got a height of 10. And so if we were to put in just some random water level, then we'd have a radius of r and a height of h. That's going to be really useful because we're going to have similar triangles there. So the next thing you do with a related rates problem is you set up a formula for the volume. For a cone, it's pi over 3 r squared h. Now, for our particular problem, notice everything is in h, including this dV dt. So we'd like to get this whole volume formula in terms of h. So we're going to use the fact that we have similar triangles. In fact, I know that r over h, radius over height, has to maintain the ratio of 8 to 10. Or that r equals 4/5 times h. Because I'm going to plug that in for this r here. So I've got pi over 3, 4/5. So that's, again, something we look for. We always want to get our formula in terms of one variable. So if I simplify this, I've got 16 over 25 and that times the 3 on the bottom, so I have 16 pi over 75 h cubed. Now I have volume in terms of h, and I know my dV dt. We weren't given any specific height, and we weren't given a dH dt. In fact, all we were looking for to see is if the tank can ever overflow. So what we're going to do is analyze dH dt, which is the rate the height is going to be increasing. So I'm going to take the derivative of both sides with respect to time. So I get dV dt equals 16 pi over 75 times 3 h squared. We can simplify that a little bit. We're going to get 16 pi over 25 h squared is dV dt. Alright, now I'm going to need a little bit more room here, so I'm going to now plug in my dV dt right here, which was, if you remember from before, I have it still up here, the 0.1 minus 0.004 h squared. Gosh, I'm sorry, and when I did my dV dt, I forgot to multiply by a dH dt by our chain rule. Okay, now what I'm going to do is I'm going to see what's going on with dH dt. So I'm going to solve this guy for dH dt. So I get dH dt is equal to 0.1 minus 0.004 h squared over 16 pi times 25 over 25 h squared. Now, let's think about what we know here. This denominator is always going to be positive. So the only thing that can be positive or negative is this numerator. So we're going to analyze what's going on with 0.1 minus 0.004 h squared. And basically we want to know where it's positive and where it's negative, so let's see where it's 0. So we get 0.1 equals 0.004 h squared. And if we divide this and take the square root, what we end up getting is h equals 5. So at 5 feet, dh dt is 0. So right when we're at the middle of the cone. Now if we analyze this a little bit, when for this to be negative, so dv dt is negative when h is greater than 5. So that means the only time dv dt is positive is when h is less than 5. So what that tells us is if the height is less than 5, then the height is increasing, but once we get to the middle of the cone, it stops increasing, and after 5 meters, it actually starts decreasing. So it will not overflow because the tank itself is 10 meters high. Once we get over 5 meters, it actually has a negative rate, so it's actually going to start decreasing.